In this example, there are again a lot of things that we need to remember how to do. So, things that we're going to be bringing up that you may not have used in a while. So, just bear with me and we'll talk about them as we go. So, this one says find all integers x, if any, that make each of the following true. So, we're going to find x, figure out what x is. Okay, so in our first problem, we have negative 3x equals 6. You always want to ask yourself when you're solving for x, why is x not alone? Well, right now it's being multiplied to the negative 3. So we want to do the opposite operation in order to undo that. So instead of multiplying by negative 3, we need to divide by negative 3. Now, if we do it to one side, we have to do it to the other side to maintain balance. So negative 3 divided by negative 3 is 1. So we'll end up with x equals 6 divided by 3 is 2. And because the signs are different, our answer would be negative. So our answer is x equals negative 2. Now for this second one here, we have x divided by 3 equals negative 12. So right now, x is not alone because it's being divided by 3. So what is the opposite of dividing by 3? That would be to multiply by 3. And that means we have to do the exact same thing to the other side. So dividing and multiplying cancels that out or makes it a 1. So we have x equals negative 12 times 3. 12 times 3 would be 36. The signs are different, so that would be a negative answer. All right, what about this next one here? We have 3x minus x minus 2x equals 3. So we have some like terms here that we can combine first. So 3x minus x, well, 3 minus 1 would be 2x's, right? Subtract and then keep the sign of the larger number. Minus 2x equals 3. So 2x minus 2x, well, anytime you have an item and you completely take it away, it becomes 0 equals 3. Now that doesn't make any sense because it's not a true statement. This is what tells you that there is no solution to this problem. There is no x value that you can use that will work in this problem. Okay. May have forgotten about those over time. And you may have forgotten about this rule here. So we have x minus 1 squared is equal to 9. Okay, so right now the x has a minus 1 being 1 is being subtracted from it, and then that whole thing is being squared. So we have to undo that. And for those of you who have a little bit of trouble figuring out which to do first, think about what I just said. So what's happening to x? We have 1 is being subtracted, right? And then the whole thing is being squared. So what we're going to do is we're going to um, remove each one of those things, and we always go backwards. So whatever I said last is what we're going to do first to correct it. So the opposite of squaring would be the square root. So we're going to take the square root of both sides first. Squaring and square rooting undo each other. Those are opposite operations. So we're left with x minus 1 equals the square root of 9, which is 3. But you may have forgotten Don't forget that could be plus or minus, because a 3, if I were to square that, I would get back to 9. And if I were to square a negative 3, I would also get back to 9. So you have to take into consideration the positive and the negative when you take the square root of a number. Well, now what this does is it basically gives us two different equations. We have x minus 1 equals 3. We also have x minus 1 equals negative 3. So now we can solve both equations. We took care of our squaring, so now 1 is being subtracted from the x. So we're going to undo that by doing the opposite, which would be to add 1 to both sides. So x will equal 3 plus 1, which is 4. The signs are the same, so we add and keep the sign. Here, when I add 1 to both sides, then I will have x equals 3 and negative 3 and a positive 1, so the signs are different. I will subtract and keep the sign of the larger number. So we actually have two solutions for these problems. And that's because it was a quadratic, which means that it has two solutions. If you remember back from your college algebra, the degree of the polynomial tells you how many solutions that you have. This last one here, we have x minus 1 times x plus 3 equals 0. Well, you may have forgotten how to tackle these, so I wanted to talk about it. Here we have two things that are multiplied together to equal 0. Well, the only way that you can get a product of 0 is if one of the factors is 0. Remember, we had that rule that said 0 times a is 0, or a times 0 is 0. So the only way you can get 0 as an answer is if one of the factors, or both, would happen to be 0. So what we're going to do is we're going to use that idea, and this is called the zero product property, for those of you who've forgotten it. So here we have either x minus 1 has to turn out to be 0, or x plus 3 has to turn out to be 0. So we are going to solve both of these separate equations by getting rid of the 1. We're going to get the x alone. So the opposite of minus 1 would be plus 1. So now I'm going to have x equals 0 plus 1 is 1. So there's one of our answers. And on the other side, we have x plus 3. So the opposite of plus 3 would be minus 3, which leaves us with x equals 0 minus 3 would be negative 3.